Good morning, everyone. Welcome and thank you for joining us in this very special event to celebrate a major milestone in the digital transformation of Latin America, the launch of the Malbec subsea cable system. I am Eduardo Falzoni, CEO of Globenet, and I am honored to be your host today. During the next 30 minutes, we will walk you through the Malbec system main highlights and benefits. I want to start by showing you a short video about the design and deployment of Malbec, the latest extension of Globenet network in the Americas. We hope you walk away as excited as we are with this big leap in connectivity for the Southern Cone. As you could appreciate in the video, the Malbec cable system is a technological breakthrough. But before I get into the system details, let me tell you a bit about Globenet. We own and operate a subsea cable network connecting North and South America and countries within South America. Our network spans 26,000 kilometers in the Atlantic and the Caribbean. It runs between New York, Miami in the US, and then connects with Bermuda, Venezuela, Colombia, and Brazil in 2 locations, Fortaleza and Rio de Janeiro. Globenet offers a range of IP, IaaS, cloud and security solutions to carriers, OTTs, cloud providers, and telecom operators in the Americas. With a neutral approach to the market and our customers, we provide connectivity services like Ethernet and wavelengths, IP transit, colocation, virtual servers, and security services like anti-DDoS and endpoint protection, all based on our own infrastructure. With the new Malbec system, we are currently extending our subsea infrastructure into Argentina, the furthermost country in South America and the second largest economy in the region. Why is this so important? Malbec is the first system of its kind reaching Argentina in the last 20 years. The new system more than doubles the total capacity that is currently available, seamlessly connecting Argentina with Brazil, Latin America, and the United States. The system runs between our cable landing station in Rio de Janeiro to a new landing station in Las Toninas, Argentina, with a branching unit to Praia Grande close to Sao Paulo. We can provide connectivity between Rio and Sao Paulo and between Sao Paulo and Buenos Aires. We also have deployed a stub BU for a future landing in Porto Alegre, Brazil. Malbec is totally integrated with the Globenet network in terms of technology and operations, meaning that both systems use the same optical technology and are managed by the same operations team and same network operations center. Now, let's talk about the design of the system. Malbec has a highly sophisticated and robust design with state-of-the-art technology to address current and future demand, both for corporate and OTT traffic. There are 4 pillars underlying the design of Malbec that provides the highest network quality and availability. Naturally, large capacity was the first one. We designed the system with the capacity to accommodate current and future demands from high traffic applications such as streaming, live sports, cloud, gaming, and in general, OTT traffic. Diversity was another important element of the design. Diversity from existing routes and infrastructure to satisfy the need for multiple accesses to POPs and data centers. We achieve this diversity not only through the new subsea route, but by building new landing stations. This way, there is no shared or common infrastructure with other existing systems. Resiliency was another major consideration to ensure reliable connectivity and business continuity to support mission-critical applications. This was achieved via interconnection with other systems on the subsea routes and via diverse backhaul routes connecting the landing stations to our POPs and to major data centers in Sao Paulo and Buenos Aires. And finally, low latency to ensure quality of experience for users of video streaming, e-commerce, gaming, live sporting events, and cloud applications. Thanks to the optimal cable route and latest advances in optical and electronic transmission, customers in Argentina will enjoy high speed and high capacity access with minimum latency. Overall, Malbec is a testament of our capabilities, expertise, and commitment to the region where we have been operating for 20 years. We are proud to remain at the forefront of the digital transformation of the Americas. I want to close by thanking you again for your time. Now, Diana Perez, our VP Sales for North America, will tell us some more about Malbec innovations and how this new system is improving connectivity for our customers in North America.
Good morning. Thank you, Eduardo, for the introduction. I am Diana Perez, North America Sales Director for Globenet, and I am thrilled to be here today to talk to you about the opportunities and benefits of the new Malbec cable system for the North American market. The Malbec cable system is a new high-capacity subsea route from Brazil to Argentina, improving connectivity for traffic from North America. By being fully integrated into our existing network, Malbec is offering seamless connectivity between the Southern Cone and the rest of Globinet's network to Brazil, Colombia, Venezuela, Bermuda, and the United States. In the past, the most southern landing station was Rio de Janeiro. The addition of Malbec takes our network south to a new landing station that connects us via subsea routes between Rio de Janeiro, Sao Paulo, and Buenos Aires, and adds new major POPs in Sao Paulo, SP4, and Buenos Aires, Pacheco and Chacarita. In particular, for the Brazilian domestic routes, this is the key as it allows us to avoid the major pitfalls of cable cuts over terrestrial paths in the Rio-Sao Paulo route, as well as reducing greatly the latency. The Malbec system will reach the cities of Buenos Aires and Sao Paulo via our own cable landing stations in Las Toninas and Praia Grande, delivering much greater high-speed access to social media content, streaming, and cloud services throughout the region. We have also deployed a stubbed branched unit for a future landing point in Porto Alegre in South Brazil. Globenet has a long history in Brazil and has a deep understanding of the Argentinian market. This gives us the possibility to enhance and increase our national and international service offerings to the region. In addition, other complementary services such as infrastructure as a service, virtual router, and our widely popular remote peering GNX allows customers to reach remote interconnection points from Fortaleza, Rio de Janeiro, São Paulo, and now Buenos Aires. Now, let's talk about the Argentinian market. Argentina is the furthest most country in the South Atlantic and the second largest national economy in South America. The country has a population of 45.4 million people, of which 92.2% live in urban areas. There are 40 million mobile telephony subscribers and around 36 million internet users, which increased by 1.2 million from 2020. All these connections generate incremental traffic, the demand driven not only by the need for greater capacity, but also lower latency and better security. To date, investments from a cable connecting the large sources of content coming from the US and Europe have been limited due to the cost and how labor-intensive these projects can be. And here we are, the new Malbec cable system connecting Argentina and Brazil and the rest of the Americas is most exciting. This is the first subsea cable system of its kind to land in Argentina in nearly 20 years, not only in terms of the advanced subsea infrastructure, but also the terrestrial backhauls and the integration of larger interconnecting subsea systems that will contribute significantly to Argentina's economy and the technological growth. The 4 pillars to support the design and deployment of the Malbec cable system are capacity, diversity, resiliency, and the reduction of latency. These are all key elements that are demanded by digital transformation. In addition, the pandemic has accelerated the need to leverage high-speed networks to reach users and deliver content, especially live streaming, gaming, and other dynamic applications. I want to focus on minimal latency achieved by our system. Globnet's existing route between São Paulo and New York offers ultra-low latency of 108 milliseconds. The estimated latency in the Malbec subsea system is 26.7 milliseconds between São Paulo and Pacheco in Buenos Aires. This low latency was possible thanks to a fully detailed analysis and definition of the cable route, which covers a shorter path from the subsea infrastructure. High video latency is caused by delays in the delivery path, which affects the user's experience, especially considering live sporting events, gaming, and live news updates. So the milliseconds of improvement offered by the Malbec system makes a world of difference to an OTT live streaming service. Another key component of the new system is its high capacity. To support the demand of the current and future capacity, Globnet's backbone is designed to support 100 gig and 400 gigs of capacity across the entire route with a broad offering of services for OTTs, e-commerce, and other applications. The use of cutting-edge technology and submarine transponders allows Globenet to offer transport services with 400 gigs and even the longest segments of Malbec, enabling ultra-fast connectivity to data centers in the major cities and POPs. And to complement the state-of-the-art technology deployed in the Malbec system, the Globenet team operating Malbec and the whole network are the most talented and highly specialized team in the region. I want to reiterate our commitment to the North American market and thank you all for the opportunity to share with you our excitement about Malbec. Again, my name is Diana Perez, Regional Sales Manager at Globenet. I want to thank you all for your time and hope you enjoy the rest of the launch. And now our CTO, Philippe Perrier, will share with you key aspects of the Malbec system technology.
Hello, my name is Philippe Perrier. I'm a Globenet Chief Technology Officer, and I'm here today to share with you some of the key technology aspects of the newly installed Malbec submarine cable system and show you what makes this system unique. The Malbec cable system is a natural extension of Globnet's subsea network, bringing a state-of-the-art, ultra-high capacity network solution to Argentina. Supplied by Alcatel Submarine Networks, Globenet developed and now operates the Malbec submarine cable system. It incorporates the latest generation of submarine cable and transmission technologies and was designed to address current and future market demands. As you heard before, there are 4 pillars that underline the design of the most southern extension of the Globenet network. The first pillar is high capacity to address the current and anticipated demands from mission-critical, high-traffic applications like streaming, live sporting, cloud, gaming, and corporate traffic, among others. The second pillar is diversity from existing routes and infrastructure to meet the need for multiple accesses to points of presence and/or data centers. A third pillar is resilience to ensure reliable connectivity, business continuity, and the delivery of crucial services. Finally, the last pillar is minimal latency, thanks to its direct route, for optimal user experience in cloud and gaming applications, for instance. The same 4 pillars or system requirements which drove the design of the Malbec submarine cable systems were also considered for the land sections or terrestrial backhauls, interconnecting the cable landing stations to the points of presence. In the remainder of our discussion, I will refer to Malbec network, the combination of the Malbec submarine cable system and of the terrestrial backhauls. Now that you are familiar with the design consideration, let's discuss the architecture of the Malbec network and the steps taken to ensure the system requirements were met. The Malbec submarine cable system connects our existing cable landing station in Rio de Janeiro to a new purposely built cable landing station in Las Toninas in Argentina. A branching unit allows to connect the Rio de Janeiro cable landing station to another new cable landing station in Praia Grande, a short distance away from São Paulo. The trunk cable between Rio de Janeiro and Las Toninas consists of 6 fiber pairs, and the branch to Praia Grande of 8 fiber pairs. The system was designed for a minimum total capacity of 108 terabit between Rio de Janeiro and Las Toninas. Referring to the diversity pillar I just mentioned, the reason we decided to build a new cable landing station in both Praia Grande and Las Toninas was to provide diversity from the existing infrastructure at both locations. Also, to address the resilience requirement, redundant submarine connectivity between CLSs is provided via diverse submarine cable system, in effect resulting in a 2-ring submarine cable system architecture. A first subsea ring between Rio de Janeiro and Praia Grande CLS, and a second subsea ring between the Praia Grande and the Las Toninas CLS. In Brazil, the terrestrial backhaul consists of 2 geographically diverse routes connecting the Praia Grande CLS to Equinix SP4 in São Paulo, and then to SP2, not far from SP4. In Argentina, the terrestrial backhaul also consists of 2 geographically diverse routes connecting the Las Toninas CLS to the Chacarita and to the Pacheco data centers in Buenos Aires. The 2 redundant geographically diverse backhauls between CLS and POPs make up rings number 3 and number 4 respectively. So as you can see, the Malbec network was carefully designed and architected. Now turning our attention towards technology. The Malbec networks makes use of the latest in subsea and transmission technologies. As an example, the subsea cable system was designed as an open cable system. An open cable system decoupled the wet plant from the transmission equipment, which gives the network operator the flexibility to select the submarine line terminal equipment from many suitable suppliers. The subsea cable system design also relies on spatial division multiplexing, also known as SDM, a novel scheme that maximizes the capacity of the entire cable rather than the capacity per fiber pair. Finally, the subsea cable system uses the latest generation of repeaters, branching units, and line monitoring, resulting in a more reliable cable system. On the dry plant side, the deployment of the latest generation of coherent transponders, capable of up to 800 gig per wavelength, make it possible for the longest digital line systems between Rio de Janeiro and Buenos Aires, close to 2,600 kilometers long, to support 400 gigabit per wavelength. Higher rate wavelengths are supported on the shorter digital line system, such as Rio de Janeiro to São Paulo. The combination of system design, state-of-the-art technology, and redundant architecture gives an unparalleled level of resilience to the network. Let me show you what I mean. Additional resilience is warranted by a meticulously designed route of the cable route. In this case, the route was developed for the cable to quickly reach deep water, where the occurrence of a cable break is less likely. Also, particular attention was paid to the type of cable armoring used along the route. And during deployment, the cable was buried to extreme depth, way past the typical 1,500 meter water depth in areas of heavy fishing activities. The transmission equipment is located at the POPs instead of at the Praia Grande or Las Toninas CLS, as you might find in older generation submarine cable systems. The terrestrial backhauls are seamlessly integrated with the subsea cable system, providing an additional level of resilience because there is now less equipment at the cable landing stations. Protection or restoration scheme at layer 0, which is the optical layer, are available end-to-end or by domain, that is at the ring level that I was mentioning before. This capability is provided through the use of reconfigurable add-drop multiplexers located at the cable landing station as well as at the POPs. Layer 1, transport, or Layer 3, IP protection restoration, is available between the endpoints of the system. As a final note, the Malbec network is fully integrated with the existing Globenet network, meaning that it is operated and managed by the same operations team and supported by the same NOC as our existing system. All in all, the Malbec network is the first of its kind to bring maximum capacity with minimum latency, connecting Argentina to Brazil, North America, and the rest of Latin America. With that, I want to thank you for this opportunity to discuss in further detail the main technical elements of the Malbec network. And now I want to show you a video to illustrate the benefits and impact of the new Malbec submarine cable system. Thank you.
Well, we have reached the end of our event. We hope you enjoy learning about the Malbec subsea cable system. This is the latest extension of Globenet network in the Americas and a clear example of our commitment to the region. As we move into a new area in the digital transformation of the Americas, Globenet continues to shape the future of telecommunications through innovation and technological advances. I want to thank you again for your time. We look forward to seeing you again. Thank you.